not turning at all. And any point in between, it's not turning a full rotation in 24 hours. So it could not stay stationary in direction. It does change.
Have we ever seen this done at the equator?
You want to go, Napalm?
I think we just talked at the same time. I don't know if he heard my question or not. His claim was that it would not move at all at the equator.
Yes.
And I'm just asking if he had evidence of that.
I have not done it there.
Are you saying that the pendulum deviates?
Deviate from what? It basically makes a figure of 8 on the ground. Yes.
The pendulum itself makes the thing, not the Earth moving.
No, I mean the Earth moving is causing the pendulum to make this movement, but it is a figure of 8 if you are not at the equator and not at the North Pole. Yes.
That wasn't a clear answer. Is the pendulum deviating, or is it not deviating? Is it going back and forth? That's my question to you.
It's deviating from a straight line. Yes. It has It actually has lateral accelerations happen to the pendulum. If you would have an accelerometer in that pendulum, you would detect left and right acceleration there.
And it's not Coriolis effect, because in Coriolis effect, the thing's just going straight.
The thing is, yes, it would go straight, but it's attached on the ceiling. So once it's deviating to one direction, the angle to the ceiling is pulling it in the other direction. That's why it's doing a figure of 8. It's
like when you have the Coriolis effect, if you were to throw a baseball, if you were to be on a merry-go-round and throw a baseball off it, you don't throw a knuckleball or a curveball. You just throw a straight shot. You wouldn't be able to measure any left to right acceleration or whatever, because it's just going in a straight line. That's what the Coriolis effect is. So with this pendulum, if you were to measure left or right, you could be sure that it's not the Coriolis effect.
No, so the baseball is not attached to the ceiling, but the reason why the pendulum is anyway going backward is because it's attached to the ceiling and due to gravity. So once you move a pendulum a little bit to the right, gravity is trying to pull it back to the center. So the movement of the pendulum due to Coriolis to the one side is then counter affected by the gravity to move it back to the center, and that's the left and right swing of the pendulum. It's still caused due to conservation of momentum, or you can call it Coriolis.
Now you're just making stuff up. Improv science, bro. Come on.
I mean, I have an example that can show you that it's absolutely not conservation of, like, Coriolis has nothing to do with conservation of momentum. But
it has everything to do with that, because the ball is flying straight.
Hold on. Yeah, it conserves its momentum in a straight line. And other than that, everything that happens whether there's Coriolis or not. There's nothing to do with Coriolis. Anyways, yeah, Coriolis, the ball off the merry-go-round just goes in a straight line. You wouldn't detect any forces, left or right, and the Coriolis effect would be happening. That's what happens when something goes in a straight line and it just appears to deviate. The Coriolis effect, there's no left to right movement. It's just going in a straight line.
Correct, but because that pendulum is attached to the merry-go-round, not at the center point, but an outside part. If you then throw the ball, it tries to go straight, but is then pulled by the attachment. Imagine not a merry-go-round, but these kind of carousels where you have these swing carousels or chain carousels where you have these seats on the chains, right? They are hanging around, but they are not hanging around from the center. They are hanging around on the outside. And this movement of this carousel is pulling on the chains where the seats are attached to. So if you then move a seat from the center to the outside, it tries to go straight to the outside, but is at the same time pulled by the turning carousel. So it would have a kind of a spiral movement or something like this.
So once again, if you can measure any left to right acceleration, definitely not going to be the Coriolis effect, because that doesn't
Jeremy,
happen in the Coriolis. That doesn't happen in the Coriolis effect. It's just the thing going straight. You're debunking Foucault himself with what you're saying. I hope you know
no,
that. Yeah.
Jeremy, I just told you there is not the ball is not attached to the merry-go-round. If you attach it, and that's what the happening with the pendulum, it's attached to the ceiling. There is other forces acting on it. And this attachment on the ceiling is pulling it from the straight path. And again, that's the same reason why a pendulum in the very first place goes forward and backward, because you move the pendulum in one direction, it would continue in that direction, but because it's attached to the ceiling, it's lifting higher, and then the gravity is acting on it and pulling it back, and that's why it's forward, going backward, going forward, going backward, because the attachment at the ceiling.
I mean, I don't know how many more times we can do this. I'm going to say my thing again. You say your thing again. But like, how long do you want to keep doing this for? I have all night.
I have to bring the kids into bed. Sorry.
No matter what you say, they're going to keep saying that the pendulum deviates. I told you, bro. Some people that will not concede this, even though you tell them, look, read Foucault, read what he says, read what the whole thing is about. Nope. I hear you, but you can't come in. I hear you knocking, but you can't come in.
Yeah, I don't think that's right. I thought the whole point of the pendulum was it's supposed to be swinging in a line and the Earth's supposed to be rotating beneath it. Right?
That's the idea, yeah.
Yeah, because if the ceiling making it swing, then that don't have shit to do with Earth rotation, right?
Well, tell
I
that
don't
to your
know.
That's what I'm
compatriots.
saying. That's what I'm saying. If you have a left to right acceleration on it, you can be sure it's not the Coriolis effect, because that's supposed to just be going in a straight line. I know. I've been trying to tell them that. We just keep going back and forth. So I don't know.
Yeah, I don't know what you talking about.
Some people think, it's not the first one that said it, and it won't be the last, that they think that the actual pendulum deviates.
Well, you can see it deviate.
There you go.
What do you mean,
Example.
there you go? You can see it fucking deviate. Are you denying that it deviates?
No, we're talking about the actual Foucault quote-unquote experiment, what that is supposed to do. I know what an actual pendulum does in reality, and I'm so glad you said that.
Yeah, the Foucault pendulum isn't a normal pendulum. It can move in all dimensions, and most pendulums only move back and forth in one dimension.
So what are you saying now?
The Foucault
What did you
pendulum is
come in to
designed to
state?
move. The Foucault pendulum is designed to move in 360 degrees motion. Most pendulums only restrict it to one dimension, a flat dimension.
Okay, so Foucault's pendulum, the so-called quote-unquote experiment. What is the pendulum supposed to do in that case?
Swing back and forth.
Thank you. So why did you come in and say something else then?
Because as it swings back and forth, it deviates, it precesses because the Earth is rotating.
No. You see,
Yes.
now you're changing it. Now
No,
you're saying two
no. What
things.
do you mean? No,
Hold
I'm not
on,
saying
because you're
two
not being
things.
specific.
I'm saying the same thing.
Hold on, Kate, hold on a second. It's because you're not being specific with your wording. What's actually moving? Is it the pendulum?
I was very specific with my
pendulum going
wording.
back and forth?
Depends on your
Hold
frame
on.
of
Let me just
reference.
phrase it correctly. That way you could learn.
I did.
Can you
I
guys
don't
hear
need
me?
you to rephrase it, bro. I phrased it very specifically. I asked him, "Is the pendulum moving back and forth or deviating?" And he said both. Maybe you weren't listening, Jeremy.
Well, it does. As it swings back
Let me
and forth,
just
it deviates
rephrase
from
it.
You
from
don't need
our
to rephrase it, bro. Let
from
him answer
our
my question, and then you
from
can answer your question. Ask your question, bro. I don't
from
need rephrasing on my question. Thank you, Jeremy.
from our frame of reference. The pendulum is deviating. That's correct.
The pendulum is deviating. Thank you.
From
Now
our
you
frame
can
of
go
reference.
ahead, Jeremy.
From our frame of reference, that is correct. You can see that.
The overall vector for returning direction, basically, right? It's kind of like the vector single or triangle vector.
You were breaking up there, bro. I don't know if you're trying to get in or.
The vector is changing.
Is he hot miking or I don't know what's going on here.
Yeah, we're just showing music in the background. I'm saying the vector is changing.
Bro, this guy's hot micing, bro. Set him to the hot mic room, please.
I just need it.
So, what are we denying the Foucault pendulum today? Is this like Friday deny Foucault pendulum Friday or something?
No,
No, we're
hold
not
on.
denying it.
Hold on. Let me just rephrase it. Real quick.
Don't
Hey,
rephrase it, bro.
the
My answer
Foucault.
was my question was answered. Ask your question. Don't rephrase my question.
Okay.
My question
It's
was said and answered, bro. Thank you.
Yeah, it's
okay. Just
showing the
relax.
rotation of
Why
the
are you
Earth.
getting all
And
fired up, dude? Hold on, Paige. Why are you getting all fired up, bro? Just chill out.
Why you
Let me
feel you need to rephrase my question, bro?
let's just see. Let me just see what happens. Just play along. Now, Paige, does the pendulum swing back and forth in a straight line, and the whole Earth's rotating, which causes it to appear like it's precessing, or does the pendulum actually is it actually turning?
yes, both those answers are correct, depending on your frame of reference.
So you don't know what's moving. You don't know if it's
Actually, we do,
the
depending on your
Earth.
frame of reference. That's correct. From the frame of reference of staying on the ground, watching the pendulum move, it appears that the pendulum deviates.
See, he said both.
That's correct. Now, if the
Yeah, but then
pendulum
if
from
he
the
says
pendulum
both, then that's not the
from
core. That's not the
from
Coriolis effect. Then
yes,
though,
it
if he
is.
says
Yes,
both,
it is.
if he
Yes, it
says
is.
both, that's not the
Listen to
Coriolis
me.
effect.
Yes,
Because
it is. Listen to me one
hold
more
on,
time.
Paige.
Listen to me one more time.
Hold on, man.
God damn it! Listen
Dude,
to
you gotta
me. You're
chill
taking
out,
my
bro.
words
You
and
gotta
you're
chill out, dude.
taking my words and twisting
Hold
them
on,
to
man. I
fit
can
your
fix
flat
this.
Earth.
Hold on. We're not gonna get all excited and shit.
You are
There's
twisting
no
my
need.
words to fit your flat Earth prerogative.
So if you don't know which one's actually moving, then you don't know. But if it's the Coriolis effect, we know that the pendulum would be going back and forth in a straight line, and the Earth is the thing that's moving underneath it. All right, he left.
I mean, you could figure it out, right? So, like, you could take it where there is no Coriolis effect on the equator, right?
No, the question here was, and he said, see, this is the thing, right? I said that in the Foucault pendulum so-called experiment, the pendulum swings back and forth. And then I said, but there's some people that think that the pendulum deviates. Then Snooze came in, and then NASA came in. So there's people out there that think the pendulum deviates. It doesn't swing back and forth, and the Earth rotates underneath. And NASA was saying both now. We say both things happen.
I mean, he's right. It's a little bit of a complicated answer to be giving, but I mean, what you're saying that it could be caused by some inconsistency in the like mechanism of the Foucault pendulum. You just move it around and see if the results are consistent in one direction or another. Then you would know that would be your problem, right? If it gives you results all over the place that don't match with latitude or, latitude, that's right, then you know that there's a deflection in the device.
No, we're still on step one. We're still on step one here. Do you think
Yep.
that in the focal pendulum experiment that the pendulum is supposed to move back and forth in a straight line or deviate? Which of the two do you think?
I mean, it's almost a straight line.
What do you mean almost a straight line?
I was looking at each individual, back and forth.
Did he just cut out and come in with the last two words, or is it me?
My bars are looking fine. Can you hear me okay now?
I can hear you now. You can hear me?
Yeah, sorry about that. I don't know if that was me or what, but yeah, like if you went to the North Pole where the alleged effect would be the strongest, you'd only see a 15 degree per hour drift. Like watching something going back and forth, let's say once every 2 seconds, I don't know that I'd actually see the deflection in it visually every second. That doesn't seem like I'd be able to see it. But if you were able to record it, have it trace a line on the floor, then that would be apparent.
Yeah, but due to what? Will the apparent deviation be due to the Earth moving underneath the pendulum, or is it the pendulum itself deviating, like Snooze was saying and like NASA was saying?
I mean, you can hypothesize either one, but if you get consistent results, like if it is the device and you move the device along latitude lines, and the number of degrees per hour consistently with that, then you can say pretty confidently, yes, it is a result of the Coriolis effect. But if it stays at that same deflection rate per hour, no matter what latitude line you're on, then you could say, yeah, there's something going on with this device.
Yeah, but
No,
the
but
thing
you heard
Snooze
what
said,
Jeremy said. Oh, here, he'll say it himself.
Snooze said that you would measure a left to right acceleration, which means it can't be Coriolis effect, because in the Coriolis effect, you would have no left to right. There's no real force there pushing it, making it deviate left to right.
Why would that be? I mean, it's an apparent force. It's not like it's not the strong or weak or nuclear, strong, weak, or electromagnetic.
It's immeasurable. You would never be able to measure it because it's not there. You would never measure a left to right force on that object.
Are you saying in principle, or are you saying practically in real life you do not measure
The real life, we throw a baseball off a merry-go-round. You throw just a straight baseball, no knuckleballs, no curveballs. You just throw it in a straight line. And somebody's standing on the merry-go-round, they say, "Ooh, look, the Coriolis effect." However, if there was a thing on the baseball to measure the acceleration, there would be no left to right measurement because it's just going in a straight line. Snooze was saying if you have the Foucault pendulum, there is going to be a left to right measurement of the acceleration. That's not the Coriolis, though. The Coriolis, there would be none because there's nothing pushing it. It's not an actual force, like you said.
I mean, apparent forces can impart an acceleration like gravity, right? So, like, just because it's not what we call a formal, it's like semantics, really. It does cause an acceleration.
And even with gravity, you can't measure it. You put an accelerometer on a thing, you can't measure it. That's what I'm saying with the Coriolis thing. If this was the Coriolis effect, there would be no left to right measurement of acceleration.
So let's just say hypothetically we do this Foucault pendulum, and there is a standard deflection on these things where it's moving. We're able to determine that it is not a result of the joint of the pendulum itself. For whatever reason, this thing is moving at 15 degrees per hour on the North Pole and then no shift on the equator. What would you say about that?
I don't know. That doesn't mean that it's the Coriolis or not. In fact, we would know it's not the Coriolis if you measured the left to right acceleration.
Sure. Let's say hypothetically, we have no idea why this thing is happening, but somebody made the prediction that this would happen. And for whatever reason, we go out and get these results. We're able to determine that it's not some external factor like the mechanism itself. We're able to confirm that this deflection does happen. Would you agree that that would be evidence for whoever's proposing that this thing is being caused by something else?
Nah, dude. If you went and did this and measured a left to right acceleration, I can tell you 100% it's not the Coriolis effect.
What would it be then?
It'd be a real force, not it'd be something other than Coriolis. You can bet your bottom dollar on that.
Yeah, well, I mean, you can't just. I don't think that makes a ton of sense. Saying if you do measure this thing, then it's definitely 100% not this other thing. You'd have to be able to say it is actually quantifiably option B, right? Otherwise, you'd have to say I don't know what.
Have you ever heard the term? Have you ever heard the term? Yeah, that's what I'm saying. I don't know what it is, but falsification is independent of replacement. Like if your idea gets falsified, I don't have to have a replacement to put in it.
Yeah, no, and I agree with you. But if the current explanation seems to explain it really well, and it predicts that this particular phenomenon is happening, and you're saying, no, it could be XYZ factor, whatever, hypothetical thing you want to propose, until phenomenon XYZ is demonstrated to exist, there's no reason that anybody should think it should be XYZ, and that explanation A is the most valid explanation until something else is demonstrated. Would you agree with any of that?
Yeah, but if we demonstrate that it's not the thing somebody says it is, we just take that off the table and then try to figure it out from there. Like I don't have anything to put in its place, so.
I mean, look, if you don't mind, I got a little bit of a hypothetical. So you tell me that force X is causing the downward acceleration that we experience on this planet, right? And I say, no, it's definitely not force X. I don't know what the alternative explanation is, but it's not force X. Just because I don't understand what you're saying about force X, and you are able to come to some kind of, like, let's say within 90% the correct answer, would it be valid for me to say, no, it's definitely not force X? That was a really bad explanation. Sorry. Or hypothetical.
I think we're veering off the basic principle of the Foucault, right? In the so-called Foucault experiment. I think the thing that maybe perhaps you're not understanding is, correct me if I'm wrong, is that the pendulum has to swing back and forth in a straight line, and it's claimed that the earth is turning underneath. I'm not saying this is what I believe, I just want you to
Uh,
understand. Do you get that part?
yes, I understand that part.
Okay, because you're saying that the pendulum deviates. So obviously that cannot be, right?
Well, I get what you're saying, definitely. But what I'm trying to drive at is like, if I do not understand explanation X from you guys, does that mean that explanation X is not valid in some way?
No, those two don't correlate. No.
Exactly.
Your
So if you don't
understanding of
understand,
something. Sorry, go ahead.
all right, yeah, like, so if I don't understand, I feel like that's exactly what's happening here with the Coriolis. You guys aren't exactly understanding what the Coriolis force is, and you're dismissing it because you don't understand it, and that's not necessarily a valid way to criticize it. You'd have to come up with a more accurate replacement.
Dude, I
Well,
understand the
you're saying we
Coriolis
don't
effect.
understand it. You think we don't understand it. I get you now. Okay.
Hold on. We understand. I understand the Coriolis effect, and I understand that if you have a left to if you understand the Coriolis effect, you would understand that if there's a left to right acceleration measured, it's not the
Hmm.
Coriolis effect.
I mean, that's my understanding is that's all it is, a very slight acceleration. I can't remember on the North Pole if it's left to right or right to left, but it's a very slight acceleration. All forces impart an acceleration.
Can you explain to me what the Coriolis effect has to do with a pendulum swinging back and forth in a straight line in your view?
Yeah,
Because the
absolutely.
Corio,
So
yeah.
a pendulum, the way the pendulum is set up, it works a lot like a gyroscope. So a spinning body wants to stay in its initial inertial reference frame. So if you go on the North Pole, is just like the easiest way of visualizing it, thinking about it. It'll want to stay in that straight back and forth line. But if the Earth is a globe and if it's spinning, then it will stay on that straight line, but the Earth will actually rotate underneath of it, causing an apparent deflection in
Okay.
its pattern.
Okay. So let's say you had an accelerometer. Let's say you had the gyroscope set up, and you put an accelerometer. So you want to measure if the gyroscope's actually deviating. You know, if there's any acceleration measured. Obviously, there would be no acceleration measured left to right on a gyroscope because the gyroscope's just not. It's just staying in its plane. That's
Sure.
the same thing with the Foucault pendulum. That's why
Okay.
you would not measure. That's what I'm saying. If you did measure the acceleration with the gyroscope, you would know it was something else, drift, something other than, you know, you're on a moving body or whatever.
Okay. Sorry, I misunderstood what you're saying. I get what you're saying now, that it's not imparting a force, it's just staying in an inertial reference frame, and it's only an apparent force because we're seeing an apparent deviation, right? Am I summarizing you correctly? Or did I lock up?
Now you're good.
Oh, okay.
So I'm curious now. How do you reconcile thinking both things happen? That the pendulum can deviate
Hmm.
and the Earth. Like I just can't. I don't get it.
Well, I mean, you understand gyroscopes, right?
Yep. Yep.
I mean, it's the same exact thing. It holds rigidity in 3D space. It will not, sorry, deviate. But from how we're looking at it, it does appear to deviate because we're actually experiencing an acceleration.
Oh, so you're saying an apparent deviation. It's not actually deviating. That's what you're saying?
I mean, I think it's a little semantic, but sure. But I don't really particularly care about the word. Something's causing this thing to deviate or apparently deviate.
Okay, I mean, all right. I mean, I don't want to stress you or anything, but I mean, it's one or the other. It can't be both. I mean, but I'm not going to press the point too much.
No, that's fair enough. I mean, apparent force. Really, what matters, I think, like I get what you're saying. I need to pick a lane kind of thing. But if this does happen, I feel like that's pretty good evidence that we're on a spinning ball, right?
Well, not necessarily. I mean,
What else could it be?
well,
Well,
first of all, I mean,
hold on, Essie, real quick. According to what Snooze just said, we know that's definitely not it, because there would, just like the gyro, there would be no left to right acceleration measured, no measurable acceleration, because just like the gyro is just staying in its plane.
I'm not saying that you're actually saying that. This type. I make a prediction. We will see 24-hour sun in Antarctica at a certain time of year. You say we don't. We both go down, and we do not see a 24-hour sun during that period. It sets. That would be evidence for your model. It doesn't matter if I understand your model or not, or if I think that there's a contradiction model. That would be evidence for your model. Is that a fair statement?
But this isn't evidence for your model anymore, because if what Snooze said is correct and there is a left to right acceleration measured, then it's definitely not evidence for your model. In fact, it destroys the whole
Hold on, I
notion.
want to finish.
It destroys the whole notion
Hold on.
that it is the Coriolis effect.
Well, I feel like that's if we did the South Pole thing and the sun did set, I feel like if I said no, that's not evidence for your model. That's just something else. It's something that you're not understanding. It's not the thing that you said, because I think that there's a contradiction in the thing that you said. I feel like that would be the same exact thing.
It's not, though, because we know how the Coriolis effect works, and we know that there's no, just like when you throw the baseball or the gyro, we know there would be no measurable left or right acceleration. So it would immediately debunk the notion that it is the Coriolis effect.
All right, what if instead of saying there's a left to right acceleration, we just say there's an apparent left to right deviation? Would that change it? Would that change your opinion on whether or not that's evidence for one model or another?
Yeah, if you went to measure it and there was no measurable acceleration left to right, then you might have something. You'd have a better case than, at least it would still be intact. The measurable acceleration completely debunks it.
No, I'm sorry. I might not have said it super clearly. I'm saying, what if the experiment only states there is going to be a deviation, not an acceleration? There's not going to be an acceleration. There's only a deviation. Then we go out and do the experiment. At that point, would that be evidence for one model?
If you say there's going to be a deviation and the deviation is caused by the Coriolis effect, and then we go out and measure the acceleration left to right, that debunks your idea.
No. You go out and measure a deviation left to right.
You don't really have much there. I don't know why. Yeah, that's evidence for your model, sure.
Okay, cool. That's all I'm asking. Like,
Can you acknowledge that once you measure the acceleration, though, it would completely debunk your notion of what was going on?
you're saying if I did the experiment and I measured acceleration and I specifically said there is no acceleration, sure, yeah, that would be evidence
If you said
against
it
the
was
model.
due to a thing, if you said it was due to a thing that didn't cause the acceleration, yeah. Like if you said it was the Coriolis effect, which wouldn't have a measurable acceleration, and then we went out and measured accelerations, your thing would be debunked, right?
Yeah, I mean, I guess it depends on like how you're measuring the acceleration, because I mean, technically it does accelerate back and forth, but I don't think that's what you're trying to say.
No, we know it goes back and forth. We're talking about in the other
Yeah.
the other plane, left to
left to right.
left to right.
Yeah. Sure. Yeah, if that's a required entailment of the hypothesis, then yes, I would say that's evidence against.
Dude, you could put accelerometers on so many things and debunk so many parts of the heliocentric model. Like if you put an accelerometer in the Cavendish balls, that's another thing now. If you measured an acceleration in Cavendish, that would debunk the fact that it's general relativity, because in general relativity, if something moves because space-time's bending, you're not going to be able to measure an acceleration. So if you put the things on Cavendish, and then measured it, that'd be a little bit more evidence towards GR. However, if you actually measured the acceleration, that would immediately debunk it.
Yeah, but the problem is more
I'm not
fundamental.
sure that. Sorry, go ahead.
I was just going to say the problem is more fundamental because there is a problem to understand the very essence of this so-called experiment. So far, 4 people don't understand what this is. And I'm sorry, including yourself.
That's fine. You can have whatever opinion about me. How much?
No, it's like not a personal thing, but you're not understanding the most fundamental thing is the pendulum swings back and forth, and the claim is that the Earth rotates under that. If you're not getting that, I mean, it's kind of like I don't know what to say. I mean,
Why do you think I don't understand that?
because you're saying that the pendulum deviates.
It apparently deviates.
So, but is it
Depends on your
traveling
reference
back?
frame. Sorry, go ahead.
Forget what it appears, right? The question is, what is it actually doing in the claimed experiment? What is it doing?
So the pendulum does deviate
Hold on,
because it
Snooze.
doesn't
Hold
know.
on.
The pendulum is just holding partial rigidity in 2D plane.
Meaning what? Is it swinging back and forth in a straight line?
Yes, from its reference frame, yes.
Only at
Why
the
did you have
equator.
to add from its reference frame? Why did you have to add that?
No, but sorry, it's only doing that at the equator or the pole. Every in
We
between,
know your
it's
thing,
not.
Snooze, but like, can I have a minute with this guy? I know what your thing is. We talked about it before, bro.
Yeah, okay, but I mean, not everyone knows everything. A Foucault's pendulum, for example, at 45 degrees, does not rotate 360 degrees in 24 hours. It does deviate also in its own reference frame.
Yep.
Okay, so Finland. Back to the original question. Are you saying that the pendulum swings back and forth, period, or is it reference frame dependent and it changes that actual motion depending on what reference frame you look at it from? Is that what you're saying? Did I steel man you
Of
correctly?
course it's reference frame dependent. Like let's say we are on a flat stationary Earth. You could have a Foucault's pendulum going back and forth, but be on a carousel around the Foucault's pendulum, and it would apparently be deviating. Of course, it depends on the reference frame.
Yeah, but the motion does not change of the pendulum is my question. It's always going back and forth no matter what reference frame you look at it from. Is that fair?
I
In
mean,
a straight line.
like the other gentleman said, yeah, in a straight line, yes. I mean, it kind of depends what latitude you're on, but yes, straight line.
What do you mean it depends? You see? You're always throwing in a qualifier.
I feel you, SE. Guys, it doesn't matter what latitude you're on. If this is doing what the gyroscope does and it's holding its rigidity in space and it's the Coriolis effect, then it's always swinging back and forth in a straight line. That's how the Coriolis effect works. You throw something in a straight line, you're on a rotating body, it appears to deviate. It looks like it deviated. It didn't actually do it, though. It actually went in a straight line. We know that because we could throw a ball off a merry-go-round.
Sure, and it retains its angular momentum. So it depends on what part of the merry-go-round you're throwing it off of, whether or not it's going to have that apparent deviation, or if it's going to apparently deviate. Yeah, that's right. But I don't understand why it's not a valid express. Like, it sounds like there's a lot of. I don't want to sound insulting, but like a lot of word games being played, like acceleration. The thing is going in a straight line. It looks like it's going in a straight line, but something is causing this thing to consistently deviate depending upon your latitude. Stop deviating at the equator, then start deviating in the opposite direction once you get past it, start heading south.
It's not actually deviating, though. It's only apparently deviating. We know that the ball off the merry-go-round, we know that actually goes in a straight line. You know what I'm saying? Like, if a plane's flying in a straight line and you're on a merry-go-round spinning underneath it, we know what's happening in that scenario. You know what I'm saying? We know the plane's not doing loop-de-loops in the sky.
Sure. So, like, what do you think is causing? Let's say that this is an observed effect. I don't know if you guys agree with that, but just hypothetically, if this is an observed effect, what would be causing it on a flat Earth?
Well, if what Snooze has said is true, I can absolutely rule out the Coriolis effect, and we can start thinking of other things. I don't have anything to replace it with, but we can be sure it's not the Coriolis effect off what Snooze said. Same thing with the Cavendish balls. I know you were like, I don't know about that, but I'm telling you, I got a quote from Professor Parks. He said I could use it as a citation. If anything moves because of GR, if anything moves because space-time's bending, you should not be able to measure any acceleration on it. So you could put an accelerometer on the balls that move. If you measure an acceleration, it's over for why those you either have to get rid of gravity being GR, or you'd have to get rid of the balls are not moving because of gravity. One of those two things has got to go.
I'm kind of curious. Do you have that quote on hand?
I can find it. Hold on. I even asked him. I was like, "Yo, can I use this as a citation?" And he was like, "Yeah, sure." That's just how GR works, though. If you know about GR, if anything moves because of it, there's no measurable acceleration because it's not a force. So I'll see if I can dig up mine in his DMs.
Sure. Like, my only concern is that, like, it seems just a little like, if you guys tell me that the downward acceleration is caused by density and buoyancy, I don't know if that's anybody's actual position here, but if I start getting nitpicky about, like, oh, buoyancy isn't a force, it doesn't cause anything, I feel like that's not really a valid criticism of your position. That just because I don't understand your position well, and that I might like nitpick on the words of it, that's not really good reason to dismiss it.
It's not nitpicking on the words. It's the physics of it doesn't work. The physics doesn't work. That is a good reason if the physics doesn't work.
I mean, the physics of mass times, or was it
Oh, I thought we were talking about
M1
Coriolis.
or
What
M2?
were you? Hold on. What were you talking about? Oh, now we're on a gravity.
But we can talk about whatever. I don't care.
Let's pump the brakes a bit. Like, let's not overdo it. You know, he's a new guy. I'm not saying you're overdoing it, Jeremy, but I'm saying to you,
That's not new,
Finland, like,
bro.
don't take it the wrong way, bro. It's all cool.
Is
No,
this guy new?
I feel like we're being.
I thought this was the flat earthers or silly guy. Is it a different
No,
guy?
no, no. He's cool. He's cool. This guy. Let's not over. Yeah, he's new and
Oh,
he's like
all right.
absorbing a lot of stuff. So yeah.
He sounds just like the other guy. All right.
I was on yesterday. I might have said silly. You might be right.
No, I got you mixed up with another guy. Whatever. It's not important.
Okay.
I can't find the citation from Parks though, because I don't know what his even his
Okay,
screen
that's
name
fine.
is. But that is what GR says. No, nothing would be measured. No acceleration would be measured. Just like when you drop something, you drop an accelerometer. You can't measure it because it's moving because of GR. You know what I'm saying? There's no actual force there. So they say, so you're not measuring a force.
If you say so. I mean, my understanding is that it causes an apparent force that you can measure a downward acceleration on this planet due to gravity. I don't
Oh,
know
you can't
physicists that would.
internally. You can't internally measure it. There's two different types of acceleration: coordinate and proper. And this is the one where you can't. One of them. The only thing is, one of them you can't measure internally. And when you drop something, you can't measure an internal acceleration. So if you were on the, if you were falling, let's say there's skydiver free falling, like you can't measure yourself accelerating. You could just say the ground's getting close. The ground's moving up to you. In fact, when we ask
I
PhD
get what
guys
you're saying.
what's actually moving, when we ask PhD guys what's actually moving when you drop something, it gets very convoluted.
Sure. Yeah, you need it to be stationary to register the acceleration. Yeah, I get what you're saying now.
I mean, I actually have an argument that Einstein debunked F equals ma, because when you drop something, mass is accelerating with no force. But according to F equals ma, if you have mass accelerating, you have a force. But here we are dropping something because of gravity, no force.
It's a dualistic system. You have to believe in these dualistic things.
Sure.
England, let me
Like
ask
I'm
you.
no physicist. Yeah,
Yeah,
what's
yeah.
up?
Let me ask you this: if we were to take two pendulums and put them side by side, two Foucault pendulums, and put them side by side. Now, use
Sure.
any word you want. Uh, let's say we put like sand on the bottom or ink. Would they trace the exact same motion or deviation or the Earth? What call it whatever you want. Will it make the same diagram?
I don't want to be pedantic. I'm assuming you mean like within a margin of error. I would say yes.
I would say yes too. If you had them both made out of the same materials and the same length of rope and all as precisely engineered as possible, I would think yes too.
I would say no way, and I would be willing to make a sportsman bet on it.
Why do you think they wouldn't be the same?
Well, for one, it's kind of like chaos theory. And number two, it's never been done. I've been searching for years now, and nobody has ever done it. Funny, like 400 years of pendulums.
What about this? What if you did one day from 1 o'clock to 2 o'clock, then the very next day do the same thing again, same exact apparatus, 1 o'clock to 2 o'clock. What if that gave you the same results? Would you say that's a fairly similar test? Why would you want to do two pendulums right next to each other?
Why not? I'm a daring kind of a guy. Why wouldn't you? But
He's
even
living on the
yours.
edge. Bro, he's Canadian. He's Canadian.
Oh shit, that explains it. Have you ever done
So,
a Foucault's pendulum?
no, I have not because I've been asking for a while now. Like, what's
Mhm.
the? I want to do two, as a matter of fact, but I can never get an answer. Like, what length should I do? What
Mhm.
size of a ball should I use? Right? And yeah, there's no conclusive thing, so I'm not gonna bother doing something if I don't have conclusive lengths and weights and stuff like that.
Yeah, they got to be pretty big and heavy. They're pretty robust things. I had one at a college I was up in Buffalo. It was kind of running all the time. I think they set it off in the morning. It was cool. It'd just go around and tip over the dominoes in a set order. But it
Right, but
was massive. The thing was like 25 feet tall, and it was like the weight on the bottom was like 200 kilos or something like that. They're hefty, so that the wind can't, cause minor buffeting in its pattern.
Right. Was it a free flowing one, or was it like mechanical?
You're talking about the joint at the top? I'm not sure. I don't remember.
Because was it in a museum or was it in a high school or stuff like that?
College.
It could have been free floating. That would be interesting to know that too, because most of them, they're like a clock, right? You can set them. If those pins don't fall in time, or if it's too fast, there's an adjustment on it. What I'm saying is, it's not like an experimental thing, right? It's like a showpiece. It always has to be right for the audience.
Sure.
So I would love to see that, right? Like two pendulums side by side. I'm willing to bet they will not trace the same thing.
I mean, don't have them too close, because they might actually if they're heavy enough. It's very slight, but over hours they can have gravitational influence over each other, or they could touch each other. So I would not have them too close. Are you talking about like literally next to each other, or are you talking about like 10 feet, 20 feet apart?
Yeah, pick a distance where you think there'll be no influence for sure. I'm not saying they're going to be touching.
Yeah. I got a question for you guys, if you don't mind.
Yeah, go.
I'm kind of curious. What do you have a map in mind that you think the Earth looks like?
You mean the shape of the Earth?
Well, I mean, I know you guys think it's flat, right? I just meant like the orientation of the continents, and if you think there's a South Pole and a North Pole, or just a North Pole, or I have no idea.
Well, I don't use flat. I use the word level. And
Sure.
if you ask me what the shape is, I'll tell you I don't know, because I haven't seen the entirety of it. And personally, I don't think anybody knows. That would be my answer.
So you don't have any kind of map you kind of look at and think, yeah, that's generally what it looks like.
Not really. How can I? How can I?
I mean, you could figure out, look on like plane flights. I don't know that you trust those at all, but you could see rough distances between, major cities, get an idea that way. And you could just place them relative to each other until they kind of line up correctly.
Oh, kind of like a puzzle, like those puzzle games.
Sure. I guess that's a way of looking at it.
This is the distance between New York, Florida and Jamaica. Here's one puzzle piece. And then here the distance
Yeah.
between there and just stick them together, you're saying?
Yeah. Eventually, just try to come up with something where the distances are somewhat consistent. I don't know. That seems like a reasonable way of trying to go about it.
Okay, but how would you determine? Because you envision a curve, right? How would you determine if the water is curving or not on this mythical ball that some people seem to believe?
Oh, how do I know that the ball is curving?
Well, no. You said
that
you measure from point A to point B, so you have a block like a Lego, like a puzzle piece, right? And then you stick them together. Now, to me, right? It doesn't necessarily say shape. Now, for you, that means a ball, and I'm wondering how does that become a ball? Like, how does water curve for you?
Well, I mean, I can see raindrops; those curve. Oceans have waves. I think water will definitely curve. I don't see why very, very large bodies of water would not be able to. I've always been kind of confused by that comment, but like quite honestly, why do you guys think that large bodies of water are unable to curve if the surface itself curves?
Well, speaking for myself, for the simple reason I've never seen water curve. I mean, I've been to Niagara Falls. I've seen it curve there. But besides that, I've never seen water curves. So for me, it's easy. I mean, I find it funny that you think that water curves and it's like as a matter of fact for you.
Well, I mean, we all agree, right? We see water curve all the time, right?
Where?
Smaller and large, somewhat larger scale. Uh, Raindrops, for example.
Oh yeah, sure, yeah. Raindrops, water
Like
tension.
water curves constantly, all the time. Waves at the beach, right? Water's always curved. I don't
Right,
see
yeah.
why it would not conform to a sphere if something was accelerating it down. You know, I have no idea why it would try to retain rigidity in space to be flat. Like,
Okay, McFinland, do large bodies of water require a
yep.
container, in your opinion?
No. Rain clouds?
We know water curves because of
Are you
surface
talking about,
tension. That's the thing, surface tension, all right? The other curving, though, the curving for the other reason is what SE's talking about.
are you saying, like, does it need a shoreline?
A container.
Yeah.
Do large bodies of water, in your opinion, and from your experience as an adult, require a container? Yes or no? And if you can you justify your response with some examples? Thank you.
I would say no, but go ahead. Go ahead, Finland.
I mean, I just find it to be, I feel like I'm not understanding the question. I guess so. Like, it does, like, an ocean necessitates a shoreline, although the oceans could be, 20 times taller, and essentially there's no land. And then no, there wouldn't, the gravity would just be a container. I,
First
I'm
of
not
all,
sure if I understand.
Eden,
Okay,
hold on.
let's start with
Eden, hold on a second.
okay, go ahead.
Hold on, Eden. First of all, large is a very vague term because it drops large to an ant, right? However, large for us, I know what you're saying. You could get a flat floor, just get a flat floor, and just
Mhm.
start putting water in the middle, and then the surface tension would just be there. Where's it gonna go?
Sure. Yeah, in that case, you don't really need a container. It's just on the floor. But if you're talking about like a pool or an ocean size amount of water, again, like you could put it on a flat surface and it would just kind of roll everywhere. Like, do you need a container? No. It'll just flow down to its lowest point. I guess there eventually you consider it contained. I'm not. I don't mean to be dissembling. I just don't necessarily understand the question.
Go ahead, Eden.
Okay, thank you. Let's take 100 gallons of water. Okay, how
Cool.
do you plan on uh okay, how would you transport 100 gallons of water? Would you use a container?
I would drink it all and then walk it to. No, I'm fucking with you. Yeah, I'd put it in a container. Yes.
Okay, what about 1,000 gallons of water? Would you require a container to move it?
Yeah, if I wanted to move it from one spot to another, sure.
Okay,
Yeah.
10,000 gallons of water?
Let's say 1,000,000. Yes, I would need a container if I wanted to move something from another spot, from one spot to another spot, and it's in a liquid form. I would need a container. Yes. Was there more to that question?
Oh, sorry, I was on mute. Sorry about that. It's okay. SE, if you want to continue, I'll formulate my question for you, McFinland. Thank you.
Sure, go for it.
No, me, I was just laughing at that thing they keep posting on the ISS when the guy squirts water all over his face. Like, and then I was thinking, I'm sure that water wouldn't harm the electronics and all that hair up there, and when they go to the bathroom, I'm sure there's a stuff flying around. Like, what an environment! Like, what a joke this is. Like, think about it. Would you just be squirting water like that helplessly?
Sure. Yeah, dude, it is very strange, dude. They're always doing like I was just typing like that. It's like a clown, you know. And I don't like call people clowns or like use that. I don't like call people that because I think it's kind of a little dehumanizing and disparaging and stuff. So I don't use that. But that guy literally does look like an actual clown. Like it actually looks like a clown. Like I'm not saying it just like he kind of does look like one, but like his whole just the smile, the whole vibe. It's like he's putting on a little clown show there. It's so goofy how they do that, dude. Like if they were really there, like it seems like there's so much footage you could get of them actually doing some interesting experiments or something that would be real, you know. But they're always just in front of the camera doing some weird little tricks, you know, and then putting that out like, look, we're on the ISS. It's like their whole thing is just convincing people of goofy things, you know, in front of the camera. It's so strange.
Yeah, good point. Like, we're not working on this experiment. Look, we're squirting water in the air. That's a great point. But the other point also is it's not safe. You have water floating around. You don't know where it's going to end up. You're in an environment that you can die at any moment, and you got like hair floating around, water floating. Like, it just doesn't make sense.
Yeah, but he's in a watertight room. I mean, it's not like there's electronics and cables and wires and laptops all over all over the walls or anything.
Exactly. Yeah.
Yeah, there's like literally laptops just there. So if one of those little drops of water, you know, went over, hit the laptop, shorted out the laptop, now what are they going to do? They have to now go all the way down to Earth to get another laptop? I mean, how many extras do they have up there? I know, there's a million reasons. It's totally impractical and just straight up dangerous.
Yeah,
what do you guys think the ISS?
Go ahead.
What do you guys think you guys, do you agree that you can see the ISS on certain days pass in front of the moon?
An object, yeah. There is an object that can be seen. Yeah. Seafoam just grabbed it the other day, live on here. He got a shot of it.
That's awesome.
Yeah.
What do you guys think it is?
It's a space station with humans in it orbiting, free falling around a sphere in a vacuum. You know.
Oh, I understand. You definitely don't believe that, but I'm curious. What do you think it is?
Well, it would be in the realm of
I've been answering
speculation.
that for a long time. It's what I think it is. It's a military drone. It's a military vehicle, because the number one objective of the military is to get a bird's eye view to see what's happening in the battlefield, right? So that's what personally, I speak only for myself. That's what I think it is.
There's also an idea
very
that
aerodynamic.
Well, there's an idea too, which there's an idea that like there actually could be a medium up there, like a superfluid or a liquid or something where you actually could throw something up there and it would actually move on its own, like a superfluid. It's almost like a. Imagine if you have like you have a stationary planar Earth, and then above, like just for the analogy, let's just say you have an ocean up there. You know, an ocean, but it's a different type of water that's able to stay up there. Like I'm just saying. And then the idea of, let's say that ocean is flowing quickly. If you then threw something up there into the ocean, as it were, into the water, it would then go along with that water. So I mean, that's just a very crude kind of way to describe it. But so yeah, there is an idea, because what's interesting is when you look at, here, I'm going to pull up, if you look in the chat, I'm going to post a few things. If you look in the live stream one text, here, I'll tag you. But you see, like, that's actually the path of the ISS. That's over like an AE map. But even if you look at it like on the globe, like it seems to make this pattern. It's like the flower of life pattern, and it matches the way a magnetic field flux lines look. So if you look at this image too, it shows it next to a ferrocell with ferrofluid with a magnetic field. So you see the striking similarity there in terms of that. Now that is like an AE map kind of layout. But then if you look at this is this one might take a minute to upload because it's a video. But basically, this one is shows sort of the animation of on the globe, essentially like what it's doing on the globe, and then with an AE map. And that one kind of shows the AE map kind of rotating, which is kind of funny. But so I'm not really like backing the whole way that's made or anything. But I'm just saying, just in general. So it's like the thing they call the ISS seems to make this like sacred geometry flower of life magnetic field pattern. So is that just a coincidence, or it just happens to be? I mean, I guess there's different, but I'm just saying with that, there is the idea that they could actually put stuff up there. Not that humans could necessarily go up there, but that you could throw an object up there, then the object would actually flow. It would move on its own, basically, with whether it's superfluid or something to that effect. So it's not really the same idea of gravity and free falling around a sphere the way a globe is. It would be kind of like an orbit, though, I suppose, but it would be above a planar surface. So I'm just saying that's just in the realm of speculation. That is one idea that has been brought up as well. So like SE said, it could be like a drone or a technology, that they may not necessarily even be telling us about. So it could be some kind of craft or something like that. Or it could be that you actually can put stuff up there, like not like humans in that way, but that you could put an object up there that would flow in that way. And then the last one that's been discussed is that it's maybe like an actual optical, like a hologram or a projection or some kind of a, like a, like the bat signal thing when you can, you can put the Batman sign for a big light and it shows it. So yeah, something like that would be able to be kind of projected. That's another option, possibility.
I'm kind of curious about the second one. If you think that that's possible, you can throw an object essentially so high that it gets into the second medium without going through the firmament or destroying whatever's protecting the dome or whatever. Hypothetically, you could put a person in there, right? So you hypothetically could get to some like weird ocean type sky space.